Now we will come to another concept known as perpetuity. Perpetuity is nothing but what you are getting for as long as you are alive. That means they are continuing indefinitely. That is called perpetuity. Normally annuities are for a fixed period. For example, if you have opened a recurring deposit account, you would be paying, let us say, installments for 60 months. Similarly, if you have taken an insurance policy, you would be paying premium, let us say, for 25 years or 30 years. So that is a finite period during which you will be making payment or receiving payment. Whereas in the case of perpetuity, it will continue indefinitely or perpetually. That means even after your death, the money will go to somebody else. Or if you have to make payment, even after your death, your legal heirs will have to make that payment. In such cases, we call such annuities as perpetuities. And using mathematical equation, we can find out the present value of a perpetuity. It is given by C by R, where C is the payment of each period and R is the rate of interest per payment period. For example, let us say you are getting 1000 rupees every month as pension for an indefinite period and the rate of interest is 10%. So the value of perpetuity, the present value of perpetuity will be 1000 divided by R, that is 10% is 0.10. So 1000 divided by 0.10 will be 10,000. So the value of the perpetuity will be 10,000 rupees. That means if you keep this 10,000 rupees in a bank at the rate of 10%, you will be able to get 1000 rupees every year. That is the money which is being given to you regularly over an indefinite period. And in the case of perpetuity, there is another slight change which we can make, known as growing perpetuity. That means instead of receiving only 1000 rupees, you may receive an increased amount every year. That means first year you may receive 1000 rupees, second year you will receive 1100 rupees every month, third year you will be receiving 1200 every month. So such a perpetuity is known as a growing perpetuity. That means there the amount which you are receiving every month grows at the rate of, let us say, 10%. So if that is given, which is denoted by a letter called G, denoting the rate of growth, then we can calculate the present value of perpetuity, growing perpetuity, as PV is equal to C divided by R minus G, where G is the rate of growth of cash flows. For example, let us say you are getting a growing perpetuity at 10%, where the rate of growth is, let us say, 5%. And if you are getting 1000 rupees, you can calculate the present value of that perpetuity by using this formula. So present value will be equal to 1000 rupees divided by R minus G. R is 0.10, that is equivalent to 10%. G is equivalent to 0.05, equivalent to 5%. So 1000 divided by 0.1 minus 0.05 will be 1000 divided by 0.05, which is equivalent to 20,000 rupees. So that becomes the present value of a growing perpetuity given R and G. Now we will go to another concept called discounting and compounding. These are called the techniques of compounding and discounting. So as we have seen in the case of compound interest, we found out that compound interest can be calculated by using a particular formula. If you go back to that formula, we find that the total amount which you will be getting at the end of the period is given by A is equal to P into 1 plus I raised to n. So there you are multiplying the present value, that is P, with a factor called 1 plus I raised to n to get an amount at a future date. So that amount A is nothing but the future value and P is nothing but the present value. So FV can be put as present value into 1 plus I raised to n. That 1 plus I raised to n is nothing but what we call it as a compounding factor. That means if the present value is multiplied with the compounding factor, you arrive at the future value. That is called the technique of compounding. So compounding technique uses compound interest formula to arrive at the future value. So whenever we talk of compounding, we always think of arriving at the future value given the present value and the rate of interest and the periodicity of compounding. And the same thing can be put in another way, like we saw in the case of present value. Instead of future value is equal to present value into compounding factor, we can make it as present value is equal to future value divided by compounding factor. That 1 minus 1 divided by compounding factor can be called as a discounting factor. So, we can get the present value by multiplying the future value with is what is known as a discounting factor. So, now we have two formulas, one for calculating the future value, which will be future value is equal to present value into compounding factor, whereas present value will be equal to future value into discounting factor. So, discounting factor is nothing but the inverse of the compounding factor, and similarly compounding factor is nothing but the inverse of the discounting factor. So, these techniques are known as techniques of compounding and techniques of discounting. So, remember that we use the technique of compounding for ascertaining the future value given the present value. Similarly, we use the technique of discounting for ascertaining the present value given the future value. So, here in order to apply this, we have to think of situations where you will have the different kinds of cash flows. So, what are the cash flows? A cash flow is either a cash inflow or a cash outflow. Cash inflow is nothing but cash coming into the entity, cash outflow is nothing but cash going out of the entity. So, a cash flow can be either a cash inflow or a cash outflow, and a cash inflow can be and a cash outflow can be of three different types, and they are, one is a single cash flow, that means you get it only once, either you give it out, that means the cash is going out, or cash is coming in. For example, you buy an asset, for that money goes out in one installment, so that is called a single cash flow. For example, you have bought machinery worth 1 lakh of rupees, so the entity pays 1 lakh rupees only one time, thereafter there will not be any payment, so it is a single cash outflow. Similarly, the entity has sold its old furniture, so it will get, let us say, 10,000 rupees. So, it is a single cash flow coming into the entity is called a single cash inflow. So, it can be either a single cash inflow or a cash outflow, that means only one cash flow is involved, or it can be an annuity. As we have seen, it can be series of equal payments, periodic payments or periodic receipts, they are called annuities. That means you keep on paying regularly over a certain period of time. For example, your insurance premiums or your bank repayments. When you borrow money, you will be paying a certain EMI, let us say for 5 years. So, that is a periodic payment to the bank by the entity, such is called an annuity. So, cash flows can be an annuity or a single cash flow, or they can be even uneven cash flows. That means money is coming to you over longer periods, but the amount is not the same every case. For example, an entity is making profits, whatever profits it is making, that is a cash inflow for the entity. So, the profit for this year may not be the same as for the next year, and profit for the third year may not be same as the second year. So, you will have uneven cash flows. So, this is the third type of a cash flow. So, we have three situations here. One is a single cash flow, second is an annuity, there is a periodic payment or receipt, and third is what we call an uneven cash flow. So, in all these situations, you should be able to find out the present value or the future value. Normally, we are more interested in present value because this is the concept which we will be using in the next 1 or 2 chapters also. When we go to a chapter called capital budgeting, there we will be talking mostly about present value. So, you have to understand as to how to calculate present value in all these three different situations. So, let us start with the first situation, that is called calculation of the present value of a single cash flow. So, there is only one cash flow. So, the amount is known, that cash flow is the cash flow which we call it the future value, that is the money which you are receiving in future. So, that is given FVN, let us call it FVN, that is future value after n years or after n periods, and you are given the rate of interest per annum, that is called R, and I is nothing but R divided by K. K is the number of time discounting done in a year. So, if discounting is done only once a year, then I and R will be same. If discounting is done twice a year, I will be R divided by 2, and so on. So, the factor 1 divided by 1 plus I raised to n is known as the present value interest factor. So, here what we do is we take present value as equivalent to future value into the corresponding present value interest factor, which you can get from the tables given I and N. So, those tables you can refer in any of the textbooks, these tables are given. Suppose I is 5 years, I is 10% and N is 5 years. So, you can look at the table and find out what is the value of present value interest factor from the table for 5 years and 10%, and that you multiply with the cash flow to arrive at the present value of that single cash flow. And similarly, in the case of an annuity, we can arrive at the present value by using this formula. So, as we know, we have got two types of annuities. One is called an annuity ordinary, where the payments or receipts are made at the end of the period, and if the payments or receipts are at the beginning of the period, it is known as annuity due. So, the formula for annuity ordinary, where the payments are at the end of a particular period, is given by PVAN. PVA means present value of annuity, N symbolizes the number of periods. It is given by A into 1 plus I raised to N minus 1 whole divided by I into bracket 1 plus I raised to N. So, A is called the constant periodic cash flow. So, if the cash flow is, let us say, 1000 rupees per month for 5 years, then N becomes 5 years, A becomes 1000 rupees, and instead of trying to calculate it for any N and I, again this is put in the form of a table, and such a table is known as present value interest factor table for annuity. So, here there is a difference. The first one, earlier we called it present value interest factor table, that is only PVIF, and in the case of annuity is called present value interest factor for annuities table, that is PVIFA. So, should not get confused between these two tables. PVIFA means it is always for annuities, PVIF is only for single cash flows. So, once the table is there, you can find out the value of that PVIFA for given I and N and multiply it with the annuity, that is the constant periodic cash flow, to arrive at the present value of the annuities. So, that way you will get, for example, if you want to calculate, let us say, as to what is the amount you want to put in a bank account, in a recurring deposit account, if you want to have, let us say, 5 lakh rupees at the end of 5 years. So, that can be calculated by using this formula given I and N. I you can take it as 10%, N will be 10 years. If the compounding is done quarterly, then N will become 5 into 4, that is 20 quarters, and I will become, if it is 10% per annum, per quarter it will be 10 divided by 4. So, using this you can find out from the table as to what is the value and multiply it with the amount to arrive at the present value. So, this can be used for different situations to find out either the present value of the annuity or even the A. Given PVA, you can find A, or given A, you can find PVA. Either way, you can use the formula for finding one of the two. And there is a slight difference between the annuity due. So, as we know, annuity due is different from annuity ordinary. Annuity due is nothing but an annuity where the periodic payments or cash flows are at the beginning of the period, whereas annuity ordinary is normally the cash flows are at the end of the period. So, here you can see the formula, there is a slight difference there. So, you look at the formula, it is given by A into 1 plus I raised to N minus 1 whole divided by I into 1 plus I raised to N into 1 plus I. That 1 plus I is an additional factor there, that you have to remember. So, whenever in an example they are asking you to calculate present value of an annuity due, you have to use the second formula. So, normally this has to be remembered, that 1 plus I is the additional factor between the two equations. And we will come to the third situation now, that is present value of uneven cash flow. That means cash flows are there at different intervals, but the amount which you are receiving or paying is not same. That means there are different amounts coming into or going out of the entity. So, in such case, you have to calculate the present value. So, that is done by calculating the present value of each cash flow separately by using the formula for the single cash flow. then adding up together. For example, let us say you have got cash flows of 3 years profits. So, in the first year, let us say you are getting 1 lakh, in the second year you are getting 1.5 lakhs, in the third year you are getting 2 lakhs. So, convert one cash flow of 1 lakh which you are getting at the end of 1 year to present value by using the formula of the single cash flow. Similarly, calculate the present value of the second cash flow, that is 1.5 lakhs which you are getting at the end of 2 years by using the same formula, and for the third year 2 lakhs cash flows to be converted into present value. Then whatever value you get in all 3 cases, they have to be simply added to arrive at the total present value of all the cash flows for all the years. That is how we have to calculate. Normally, the last one is very common in most of the business situations, because cash flows normally are not same, are not constant. Therefore, we may have to use the last one in most of the situations in real life. Now, we have considered so far the techniques of discounting. Now, we will go to the techniques of compounding. As I have already said, compounding is nothing but the inverse of the discounting, or discounting is nothing but the inverse of compounding. So, one is the inverse of the other. So, in the case of compounding, what we do normally, we want to find out the future value given the present value. In the case of discounting, we found out what is the present value given the future value. So, the opposite is true in case of compounding. Here also, like in the case of the technique of discounting, we have 3 situations given the different types of cash flows. So, the cash flows again can be single cash flow, an annuity, or uneven cash flows, and the same formula is used. In the case of a single cash flow, we use the formula future value is equal to present value into 1 plus I raised to n. That 1 plus I raised to n is called the compounding factor, and that compounding factor also is put in the form of a table for ease of calculation, and that is known as the future value interest factor. So, future value is always given by present value into future value interest factor for given I and n. Therefore, you have to remember that whenever you want to calculate future value, you have to go to the future value interest factor table. Whenever you want to calculate present value, you have to go to the present value interest factor table. So, present value is equal to future value into present value interest factor table. Similarly, future value is equal to present value into future value interest factor table. Similarly, in the case of annuity, the formula is given there. So, there we can calculate the future value annuity by multiplying it with A by what is known as a future value interest factor for annuity given by the formula 1 plus I raised to n minus 1 whole divided by A. So, this is also again put in the form of a table known as the future value interest factor for an annuity, simply called FVIFA. So, if you want to calculate the future value of an annuity, you multiply A with the future value interest factor for annuity. And if you go back to the present value annuity, there we had used the formula present value annuity is given by A into present value interest factor table for annuities. Similarly, here future value for annuity is given by A into future value interest factor table for annuity. That means, basically it is the same thing. In one case, we are using what is known as compounding, in another case we are using discounting. So, in the case of compounding, we want to find out the future value. That means, we want to know what is going to be the future value. Discounting is used when we want to know the present value. So, here also again we can have annuity which is ordinary or annuity which is annuity due. That means, payments either at the beginning or at the end of the period. In the case of an annuity due, where the payments or receipts are at the beginning of the period, it is given by slightly different formula. If you look at the formula, you will find that there is only one addition, that is 1 plus I is added into the bracket. That is the only difference between an annuity due and an annuity ordinary, whereas the rest of the things remain the same. This is also given in the form of a table. The first bracket will be in the form of that future value interest factor annuity table. Only that 1 plus I you will have to add it and multiply with A and the future value interest factor for annuity table. And in the case of uneven cash flows, as we discussed earlier, in the case of present values, here we have to find out the future value of each of the cash flows separately, then add up all the future values to arrive at the future value of the total stream of cash flows. Normally, this is a situation which we encounter mostly in most of the real life, where cash flows are uneven. Then you need to calculate cash flows, future values of such cash flows separately and then add up. So, with this we come to the end of this session on calculation of interest.